Students, I think probably the Prashant is posted two questions he posted here. It is I am discussing the solutions related to the yesterday question paper. Question number 16. The ratio the ratio of specific heat gamma of an ideal gas is not given, which is wrong. That is asked here. Here we know that gamma equal to what it is. We know that Cp divided by what? Cv. This equation we know that. And another one is Cp minus of Cv equal to what? R. This equation we know that. Here gamma can be represented in different form, Cp by Cv or like this. Okay. Here first one, dividing by Cp, that is dividing by Cp. You see, Cp divided by Cp equal to, sorry, I made mistake, Cp minus Cv equal to R. Dividing by Cp on both sides, what you will get? Cp by Cp minus Cv by Cp equal to R divided by Cp. Of course, this will be 1 minus 1 by gamma equal to R divided by Cp. This we know that because this is 1 by what? Gamma. Rearrange the terms. 1 by gamma equal to 1 minus R divided by what? Cp. Then simplify it. This is equal to Cp minus of R divided by what? Cp. Or else we get that gamma equal to Cp divided by Cp minus of R. Yes. Okay. This is the equation for gamma in terms of Cp. Okay. This equation you check it. Right or not? 1 divided by Cp minus of R divided by Cp means this it is. You are getting Cp divided by Cp minus R. Okay. This also right. It is not wrong. That means we can represent gamma in this form also. Okay. Next. This is not wrong. Okay. Next one, that is dividing by Cv I am doing. Dividing by Cv I am doing. Okay. Before that, 1 minute. Cp minus of Cv equal to what? R. Okay. Dividing by Cv. What will get here? Cp divided by Cv minus of 1 equal to R divided by Cv. That is gamma minus of 1 equal to R divided by Cp. Therefore, gamma equal to R divided by Cv plus of what? 1. Not, sorry, it is not gamma. It is gamma equal to this. Okay. That means this equation is also right. Or we can write gamma equal to 1 plus R divided by Cv. Okay, this also we can represent in terms of what? Gamma. But our question is not given, that is yes. No? So that let us check for this one, that is. Even this also not possible, that is. So that according to me, this equation, that is, it is not equal to gamma. It is not equal to gamma. So that here option C, that is what? Option C. Even option D is also wrong, that is. Okay. According to me, the C will be the right answer. C will be the right answer. Okay. But in the solutions, what they given, you check it. That is according to me C. Even I tried it also. You will not get in terms of gamma. You will not get that. Okay. Check your solution. That is. C. Yeah. Next one is a wire of length L is bent in the form of a circle. Okay. A wire, this is the wire of length, it is what? L. It is bent in the form of what? Semicircle. It is like this. Okay. It has a charge is Q. Then electric field intensity at the center of the square is this. This is the center. Here the charge is what? Plus Q. It is what? Plus This is R is the what? Radius. This is R is the radius. Yes. He is asking at this point. What I am doing is, I am considering a small element. I am considering here, that is the small element. This element is what? DL, that is, join it. Join it. This angle is d theta and this angle is what? Theta. This is the point I want to calculate. This will be produces the electrical field. It is because it's the positive charge. That is what? DE is the electrical field produced by this element DE. I will resolve into two components. This is DE cos theta and another one is DE sin theta here. Sin theta. After this, clear. Now what I am doing is, I am considering diametrically, that is what mirror element I am considering here also. This length is also what? DL. This also produces the electrical field like this, DE. It is again resolved into two components. This is DE cos theta and another one is what? DE sin theta. Look into this here. Cos component will be cancelled because one is acting like this and another one is acting like. Only the sin component will contribute for this. Now, because D cos theta, D cos theta get cancelled for each element, due to a mirror element, remember please. Imagine yourself, take a banger, break it, it is like this. This is one element, this is another element. These are the two mirror elements you can get. Okay, fine. Now, the net electrical field, E net equal to, integration of dE into what? Sin theta, that is. Okay. This is equal to, can I write dE equal to 1 divided by 4 pi epsilon naught into dQ divided by r square into what? Sin theta into what? D theta. Fine. Now I want to find what is the value of dQ, that is I want to find it. Okay. Another thing you remember, students, here in the geometry we know that this length is dl, this is r, this is what? D theta. In the mathematics we know that dl equal to r into what? D theta, or else dl by r equal to what? D theta. This we know. Okay. Next, here there is it has charge Q, then electric charge per unit length. Lambda is called as in what? Charge linear charge density. Linear charge. Charge density, how you are writing? Q divided by what? Pi r. That is what? Total charge divided by what? Total length here. Because total length semicircle is, it is pi into what? R. I want to find what is the charge deposited only on this element. It is what? dQ equal to charge per unit length multiply by what? dl. It gives what is the distribution of the charge on this element. I think it is clear for us. This factor what it represents? Per unit length. That is multiply by what? dl. It gives the small distribution of the charge on the element what? dl, that is gives here. Okay, fine. Next, we know that dl by r equal to q divided by pi into what? D theta. Do you know why I am converting this? Because I am integrating with respect to d theta, no? Variable factor. So that I'm converting into variable factor of what? D theta I'm converting this. Okay, fine. Now, E net equal to integration of 0 to what? Pi, because I am calculating from this element to what? From this point to what? This point. 0 to what? Pi I am doing. Okay. It is 1 divided by what? 4 pi epsilon naught, correct? Into r square. Okay, fine. It is what? R square into dq equal to what? You substitute. The dq value is what? Q divided by pi. Okay, this value dq by pi, q by pi into what? Sine of theta into what? D theta. Here your all answers are in terms of L, is that no? So that it is better to convert in terms of L. How it is? We know that semicircle now. For the semicircle, pi into r equal to what? L. Therefore, r equal to what? L divided by pi. That is what? R equal to L divided by pi. Okay. Now, E net equal to, in the solution he has taken the cos. That is wrong. It is 1 divided by what? 4 pi epsilon naught into 1 divided by. Okay, 1 divided by. Okay. What is that? Okay, this value also I am writing 1 pi into what? Q into 1 divided by. What is r square? R square equal to what? L square divided by what? Pi square into what? Sin theta into what? D theta. Okay. Now you check it, students. This pi, this pi, this pi, this pi square get cancels. Here E net equal to which are the constant here? Q is constant, 4 epsilon naught into what? L square integration of 0 to what? Pi into what? Sin theta into what? D theta. Now this one equal to Q divided by 4 epsilon naught into what? L square integration of sin theta equal to what? Minus of cos theta. It is 0 to what? Pi. Then simplified. Cos of 180 equal to what? Minus 1. Minus of minus plus. Again cos of 0 equal to what? 1. It is all together just simplified. You are getting 2. You are getting that spot. I don't want to do in detail. So that E net equal to Q divided by 4 epsilon naught into what? L square into what? This two get cancels. So that E net equal to Q divided by 2 epsilon naught into what? L square. This is the right answer. Okay. In question number 16, that is according to me, that is even I tried also. This is you are not getting that. Okay. Even I will. You're supposed to get gamma. You never get that. So that C is the best. Okay. Now stop it. Thanks.